Hi, welcome to myprojectbazaar.com. In this video will lead us to complete demo of an adaptive system based on roadmap profiling to enhance warning messages disseminations in VANets. In recent years, new applications, architectures and technologies have been proposed for vehicular ADAS networks. Regarding traffic safety applications for VANets, warning messages have to be quickly and smartly disseminated in order to reduce the required dissemination time and to increase the number of vehicles receiving the traffic warning information. In the past, several approaches have been proposed to improve the alert dissemination process in multi-hop wireless networks, but none of them were tested in real urban scenarios, adapting its behavior to the propagation features of the scenarios. In this paper, we present the profile-driven adaptive warning dissemination schema designed to improve the warning message dissemination process. With respect to previous proposal, our proposed schemas uses a mapping technique based on adapting the dissemination strategies according to both the characteristics of the street area and the vehicles are moving and the density of vehicles in the target scenario. Our algorithm reported to noticeable improvement in the performance of alert dissemination process in scenarios based as real city maps. Next we are going to see the complete flow of this process. For this one, first we need to initialize that VANet network. For creating that VANet network, we are creating set of vehicles and creating the roadmap for this processing. And we have to setting the routing and noding XML files for the basic configurations. These configuration files will be getted from that OpenStreetMap. Next we have to computing that velocity of roadmap. This velocity will increasing that traffic. After that we have to analyze the algorithm based scenarios approaches for the computational environment. After setting that VANet environment and computation of that velocity, we need to analyze the scenarios for transmitting that messages. This scenario will considering the three kind of scenarios: complex scenarios, open scenarios and reduced scenarios. For this one, next we need to starting that sumo simulation. In this sumo simulation, we have to set up that environment for moving vehicles. After this, we have to analyzing the trace file for this moving vehicles. Then we have to connecting that OpenStreetMap graph to this sumo simulator to executing the traffic analysis. For this one, we have to setting upon that velocities for each vehicles. If that velocity will be greater than or lesser than the minimum maximum values, means the message will be dropped and the scenario of this vehicle will be getting changed. Else that message will be sending to that another vehicle based on the scenarios. Finally, we can get in the results of transmission of messages and warning alerts. Next we are going to see the complete demo of this process. For this process, first we need to run the sumo sim1.java. To running an adaptive system based on roadmap profiling to enhance warning messages disseminations in VANets, requiring that routing file for configuring that VANet networks. For this one, we have to choosing that routing.xml file to computing that VANet network. For this one, I have to initializing that set of vehicles in that VANet environment. Next I am going to be configuring the network for this VANet. For this one, I have to choosing that net.xml file and the netconfig.xml file. This will be showing that pre-processing level and the input nodes. Then I have to setting that sumo configurations for simulation environment. After that, we need to settings that number of vehicles as a node and their communication between that vehicle as that edges. For this one, I have to choosing that node file and also a edge files. In this node file will containing that each vehicle's XY positions and their velocities and their speed up and their identifications. That same that edge file will containing that what are the vehicles communicating between them and what the messages will be transmitted through this vehicular networks. Then we have to settings that environment for executing that VANets. So this will be that demo for this processing. Here we need to choosing that roadmap for computing that processing. Here I am going to be choosing that quiz.config file for my roadmap. This is my roadmap in between that area of 0 meter to 100 meters. I can able to zoom this roadmap for setting up my environment. After that I have to choosing that simulation. After completing this simulation I am moving to that my running window of Java frames. Now that simulation will be completed successfully. Then I am moving to that running window, which is be monitored by that vehicular networks. Now that vehicular networks will be sliced and that connecting to that simulations. This will showing your simulation environment ID and their IP and their communication port number. Each and every network will be communicated through these port numbers. Finally we have to getting that message is transmitted between the vehicular ADAC networks in the time of vehicular moving. Finally I have to applying the results for alert transmission. It will showing that number of queries transmitted between the vehicles based on the warning messages in the scenario prediction mechanism. Finally we move to the next frame and clicking that checksum mechanisms. The checksum mechanism will used to verify the integrity between the message transmission in the vehicular ADAC networks. Finally we can able to viewing the results based on trace results and view results. This will be showing that number of messages and the number of warnings transmitted between that environment. Finally we can able to viewing that roadmap. In this roadmap will showing that the road between that global network. In this roadmap will showing that vehicular network in that real-time world. So here we have to taken as that input roadmap from this site. We have to choosing that north of this roadmap to computing this vehicular ADAC network. From this one we can able to achieving that our warning message transmission based on that scenario and the velocity of that each nodes in that vehicular ADAC networks, and computing their level of scenarios will improving that message transmission rate. Thanks for watching.